Hello everyone, so this is the final topic for this module, Science, Diversity and Cycle. So we are going to discuss and explore more on designing assessment for science. However, we are not going to put it specifically in the topics diversity and cycles, but rather we are going to look at it generally on how do we execute assessment for science in a primary school. So by the end of this lesson, you should be able to, firstly, explain the purpose of assessment in science, and secondly, to explain the different vehicles of assessment in science. Assessment of pupils' learning can be used for a number of purposes. It can be used to inform teaching, to measure educational attainment, to inform learners, parents, and carers, and to help form judgment about schools and schooling. Assessment of science learning ensures that we, as teachers, know who in our class is grasping the often challenging concepts and skills that we teach, who is partway there, and who is struggling. This knowledge means that we can then respond by tailoring further lessons to suit your students' need, the individual learners. One particular term that I want to bring to your awareness would be the term called metaconnection. Now, I think most of you will know what metaconnection is. That is connection about cognition, or thinking about thinking. Learners needs to know what they know and understand, what they don't fully grasp, and what and how they learn. Clearly here, assessment has the potential to contribute to the learner's understanding of themselves as learner. As learners, we learn better if we are engaged with our own learning processes. Now, this ties well with science, as we often take a little time to fully appreciate ideas and concepts, so it can be helpful to adopt a reflective approach to our own learning. They can ask questions like, do I really understand that? Can I explain these to others? As a teacher now, you have to be able to explain to others and provide your students with experiences which will lead them to learning this kind of thing. They are aware whether they are able to explain the concepts to others, or can they actually understand the whole thing that you have taught. As a primary teacher of science, you need to know a little about some basic principles around assessment. I'm sure that most of you readily know what formative and summative assessment are, as most of you are not, or all of you are not even the first year student. You might have encountered module called assessment in learning or assessment of learning. So by any means that you are not sure, please click on the YouTube link in the PDF version of this slide to have an overview of what the two different assessments are, which are summative assessment and formative assessment. Okay, now let's look at assessment in science classes in a more specific manner. For some teachers, assessment of science can raise a number of challenges. These challenges occur when the area of science is not fully understood by the teacher. They also occur if the learners are working in pairs of groups, or if learners are talking and doing rather than writing. So confidence in your own science knowledge and skills will help you enormously. If you have to assess whether children understand a concept called dissolving, for example, you need to understand it yourself first. Now, this will allow you to spot misconception when they occur. Let's see, the second point, subject knowledge is not the same as science understanding. What are the difference? Now, let me explain. Subject knowledge is perhaps the most straightforward aspect of science assessment. For example, you ask a class of 5-year-olds to sing the action songs, the head, shoulder, knees, and toes, and see if they point to the right body parts. So if they do, then it is clear that they know where these body parts are. Lots of other science activities reveal this kind of knowledge. However, science understanding is a little more difficult to detect. For example, we may ask the class, how does air resistance affect the way objects fall? Whenever we ask for an explanation rather than simply recall of knowledge, learners are more likely to experience difficulty. Here, we may ask specific questions, or more simply ask the child to explain something orally to another child, or to create an explanatory poster. Okay, so we are clear now that sign understanding can be assessed, however, it can be rather complicated. Now, one way to actually assess these skills, these complicated skills or science understanding, is through what we call the pupil self-assessment record. Of course, the learners will know whether they know, understand, or can do things, so pupil self-assessment can save you a great deal of time. In the next slide, we are going to go deeper and look at the different ways of carrying out assessment. But before that, another way would be role badges. When you have learners working collaboratively in science, which happens most of the time, it can be difficult to determine whether each person have developed a specific skills. Different approaches can be taken. Now, one is to assign roles to each person in the group so that you can assess them in their role. For example, see the set of these possible badges in the slide. We have checker, we have equipment manager, reporter, team leader, so on and so forth. So this role can be rotated so that everyone learns some new skill whilst taking up the new role and demonstrate their competencies to you. Hence, the assessment is more transparent for the students and they know how are they doing in demonstrating this kind of competency as they learn science in your classroom. So as mentioned in the learning outcome earlier, you have to be able to explain the different vehicles for assessment of science. Now here I've posed up 6 different vehicles for assessment in the science subject. However, I'm sure you can think of many more. Alright, so we are going to discuss these 6 in this recording. The first one is called elicitation. We advocate elicitation at the start of each topic. For example, when approaching a science topic on forces, you might ask learners to complete a concept map or to discuss a concept cartoon, or you give them simple investigation that they can carry out so that you know what they already know about forces. Okay, so your observation from all these activities will give you the opportunity to find out, or in other words, elicit what the learners know or don't know, or so later you can teach accordingly. There is little point in planning and delivering 3 or 4 science lessons on a topic if they already know everything you wish to teach. Now, please be careful about this. Better to elicit their present understanding and then move them on. This might require more challenge, going back over basics, or shifting the emphasis more to science investigation. Now, elicitation is in fact just another form of formative assessment, correct? Which is used specifically, for example, at the start of a topic to inform your lesson planning. Next, on quizzes and tests, it is, of course, a teacher can write a quiz or a test, but it's also fun to ask the students to work in group to write their own questions and answers and see if they can grade the questions they come out with from easy to hard and award points according to the easiness of the questions. However, you must bear in mind that this kind of assessment can only be done when your students are able to read adequately, or else it won't be fair for them. Next is what we call here is the answer, what's the question method of assessment. Now this is a very simple and revealing approach. For example, we may ask the students if the answer if this is the answer, then what is the question? Here I've included an example for the topic of space. So if you have or you give them the answer sun, then what are the questions? So it triggers critical thinking in also checking the understanding of what they know about sun. Very quickly, the next assessment method is called the KWL chart. I think most of you will have seen this if you have been placed in Taylor's International School before. So here the learners will complete 3 columns as appropriate. In the first column, the learners need to note what they have already known. Then they need to list the things they would like to know. And finally, perhaps at the end of the unit of work, they write about things that they have now learned. So this train their metacognition and help them in understanding what they have not learned and will learn and they want to learn. So it makes learning more obvious to them. Now the next one is role play, where this role playing can also reveal knowledge and understanding in science. A classic example would be a class in the school hall modeling the solar system. To represent the different planets, children might hold things that represent the planets, like balls, labels, or posters. So up to 9 children orbit one children who represents the sun. Learners might be asked to produce a commentary for the models or instruction on how to make it work. They might be asked to describe the motion of, for example, Jupiter in relation to the sun and the other planet. So the use or misuse of any terms like spin, turn, rotate, year, and orbit can tell us a lot about your students' understanding, whether they have the language of science or not. Okay, so this means that role plays can be used to great advantage for assessment, especially when it comes to the usage of scientific terms. Another example would be to challenge the class in group of around say 8 people to form a parts of tree. Some could be the roots, some the stem and branches, and others the surrounding bark. So can they fit themselves together to be a whole tree? Can they role play the journey of water from soil to leaf tip? So all this comes into play, and you can really see the understanding or the misunderstanding about anything that you are getting them to role play in. So the last one would be on written tests. Written tests have a place in primary classrooms as another layer in the assessment approach you might take. They might be published tests written by yourself or written by the class. So the questions can include the true and false statements, linking a word to a picture, labeling part of diagrams, filling the missing word, multiple choice, or get the students to explain why something happened in the written form. Now, this can be very time consuming to produce, so most teachers will look for a published scheme of question, which ideally will cover most aspects of science, which have been trialed, have a marking scheme, have a diagnostic element, and not be over-facing. However, the big advantages about this written test is that it rely heavily on learners' reading skills, and also it cannot assess some aspects of science. For example, you can't really assess student science skills through their writing, and sometimes it cannot assess well some parts of science like the understanding of the relative motion of Earth, Sun, and Moon, like what I've said earlier. In addition to that, the students will also see that science is a rather dull paper-based exercise. So overemphasis of written assessment can begin to put some learners off learning, put them off science learning, all right? So this written tests should be used with care because they can provide useful backup to other methods adopted, but should not be overused or overemphasis as disadvantages are present here. All right. So let me conclude the whole topic here about assessment. The different approaches to assessment, coupled with your use of what you discover about learners, offer you, as a teacher of science, the most powerful tool for raising expectations about people's learning in science. Now, I encourage you to be transparent with learners about assessment processes in science and encourage them to be increasingly reflective about their learning of science and how they themselves learn science. Okay, so the knowledge, understanding, and skill that they develop now or through you later will enable learning in other areas as well, not only in science, okay? But above all, it allows them to gain from all that science has to offer. You'll be able to respond in different ways. For example, if at the start of the topic you discover what they have already known, and move them on to new or more challenging content instead of going on and on about a topic or something. Okay, so it is important as part of assessment to diagnose your students' understanding through elicitation earlier. So that is one part that differentiates science instruction and assessment from many other subjects in the primary school. Okay, so thank you for listening. This is the end of the recording.